Hello, this is Professor Brown Cedarberg, and we are going to talk about the phenomenon of integer division in Java. Integer division is the division of one integer by another and the resulting truncation of any decimal value. If I were to divide one integer by another, let's take 10 and divide it by 3, you and I know that that will produce 3.3. I'd like to send that to system.out.println, print it to the screen. So I expect to have printed to the screen 3.3. We'll compile and then run our program, and we find that what we have printed to the screen is not 3.3, but rather 3, because an int divided by an int results in an int being returned. We have the truncation of the decimal value. Now we have a few ways to work around this. What I could do if I'm dealing with numbers, specific numbers, is simply add a 0.0 to either number. And in doing so, I have said to my compiler, this is a double. A double divided by an int will return back a double. We always return back a number of the greatest sophistication, of the most sophisticated number in the arithmetic calculation. So here a double divided by an int will return back a double to me. And so we'll compile and then run, and we'll get what we expected, our 3.3. Now here I'm dealing with specific numbers. Were I dealing with variables, and let's create a couple of variables. We'll have an int, we'll name A. Let's just clean that up a bit. And we'll give A a value of, let's give it a value of 9. And we'll have a variable B, we'll give it a value of 2. Now, if I were to divide A by B, I know that mathematically I should get 4.5. But here, if I have in my println statement A divided by B, what I'll have printed to the screen, we'll compile and then run, I'll have not 4.5, but rather I'll have 4 printed to the screen, because truncation has occurred. Now when dealing with variables, I have a way of working around the problems of integer division, and that's through casting. And what I'll do is I'll cast one of the elements, I'll do A, into a number of higher sophistication, a non-int. So here I will cast A into a double. A will then be interpreted as a double by my compiler, and a double will be divided by an int. I'll have a double returned back. So let's compile this and then run it. And with that casting of our value A, indeed I have 4.5 printed out. Now, one error that's very common is for students to cast not a specific element of the calculation, but rather the whole calculation. If I were to cast what is returned back when A is divided by B, as I have here, and I cast it into a double, I will get not the correct value, but rather an incorrect one. We'll see that I'll have returned back to me 4, because A has been divided by B, an int by an int that returns an int. That value is then cast into a double, which results in simply 4.0. So this is an incorrect way to cast a value in order to get around integer division. We want to cast a specific element within the calculation, not the result of the calculation. So now when we compile and when we run, we have the expected results. Integer division is the throwing away of the decimal portion of that which is returned when an int is divided by an int. We can work around that by explicitly making one of a specific number. If we're using a specific number, make it a double with a 0.0 appended to it. Or if we're dealing with variable names, cast that into a double with this, the word double in parentheses. Float will work also, but a double is typically what we use. So here we've looked at integer division and how to get around it. Thank you very much.